Hi, hello friends. Welcome to Indian Tech Guru for you. In this video, let us solve the 0 by 1 knapsack problem using set method. 0 by 1 knapsack problem using set method. So to solve this problem, first of all, we'll be given some data. What is the data is maximum capacity of the knapsack, M, and number of items, N, and profits of each item, Pi, weights of each item, Wi. So this much data is given. So first of all, let us assume that the maximum capacity of the knapsack M is 8 and the number of items are 4 and profits of each item because there are 4 items. So P1, P2, P3 and P4 is equal to 1, 2, 5 and 6. Weights of each item W1, W2, W3 and W4 is equal to 2, 3, 4 and 5. So this is the given data. Now we need to solve this 0 by 1 knapsack problem using the set method. So solving this problem is nothing but whether a particular item must be inserted into the knapsack or must be discarded without inserting the item. So that decision is generally determined based on the xi values. Xi is equal to x1, x2, x3, x4. So the xi values are nothing but if at all the item is completely inserted into the knapsack, then xi value will be 1. If at all the item is completely discarded without inserting into the knapsack, then xi value will be 0. So by solving this problem, we need to determine, as there are 4 items, we need to determine the values of x1, x2, x3 and x4. For that purpose, we may use two different methods. One is the tabulation method. The second method is the set method. So in the previous video, we have already discussed the tabulation method. Now let us discuss the set method. So as far as the set method is concerned, to determine a set s power I plus 1, the formula is s power I union s1 power I. So this is the formula to determine s power I plus 1. So as there are 4 items in this particular example, we need to determine s power 1, s power 2, s power 3, s power 4. So as s power I plus 1 is s power I union s1 power I, s power 1 is nothing but s power 0 union s1 power 0. Similarly, s power 2 is s power 1 union s1 power 1. Similarly, s3 is s power 2 union s1 power 2. And s4 is s3 union s1 power 3. So using this particular formula, we have determined the values of s power 1, s power 2, s power 3 and s power 4. Because there are 4 items, we need to determine up to s power 4. So to find out s power 1, we need s power 0 value as well as s1 power 0 value. So s power 0 value will be initially 0 comma 0, because s power 0 means zeroth element, because there is no zeroth element existing. So that's why the values, initial values of s0 will be 0 comma 0. Next, what shall be the s1 power 0 value? So we're going to get the s1 power 0 value by adding the corresponding profit as well as the corresponding weight of s power 1, that is first object, by adding the corresponding profit as well as corresponding weights of the first object. So now let me add 0 plus 1, 0 plus 1. Here the ordered pair represents the first value as profit, the second value as weight. So 0 plus first item's profit 1. So 0 plus 1, comma 0 plus first item's weight 2, 0 plus 2. So that is equal to, it is 1 comma 2. Now we can easily determine s power 1. S power 1 is nothing but s power 0 union s1 power 0, that is 0 0 union 1 comma 2. So that will be 0 comma 0 comma 1 comma 2. So this is the value of s power 1. Now based on the s power 1 value, we can determine s power 2, but we need a s1 power 1. So how to get s1 power 1? So whenever we need to get s1 power 1, what we need to do is we need to add each ordered pair of the set to the second item's profit as well as second item's weight. That is 0 plus 2, 0 plus 2 is 2, next 0 plus 3, 3, comma 1 plus 2, 3, comma 2 plus 3, 5. So this set is represented by s1 power 1. Now because we know s power 1 as well as s1 power 1, we can easily determine s power 2. S power 2 is nothing but s power 1 union s1 power 1. So 0 comma 1, 1 comma 2, 2 comma 3, and 3 comma 5. So this is the s power 2 value, s power 2 set values. Now as we know s power 2, we can determine s1 power 2. S1 power 2 is equal to, we need to add the third item's profit as well as weight to all the elements. So third item's profit is 5, weight is 4. So the first element could be 5 comma 4. The second element is 1 plus 5, 6. 2 plus 4, 6. The third item is 2 plus 5, 7. 3 plus 4, 7. The fourth item is 3 plus 5, 8. And 5 plus 4, 9. So these are the S1 power 2 values. However, if you observe the elements in the S1 power 2, the first in the order pair, the first element always represents the profit, the second element always represents the weight. And if you observe the last ordered pair, so 8 is going to represent the profit and 9 is going to represent the weight. However, as the maximum capacity of the knapsack is 8 only, we cannot insert an element with the weight of 9 that is greater than 8. So this particular ordered pair is discarded. So whenever the weight is greater than the capacity of the knapsack, then that ordered pair is discarded. Now Let us try to determine the s power 3 value. As we know, s power 2 and s1 power 2, just union these two, then we get 0 comma 0 comma 1 comma 2 comma 2 comma 3 comma 3 comma 5 comma 5 comma 4 comma 6 comma 6 comma 7 comma 7. So this is the resultant s3 set, s power 3 set. So however, here also we can eliminate some of the ordered pairs based on the dominance or purge rule. Dominance or purge rule. So this dominance or purge rule says that if pi is less than or equal to pi plus 1 and wi is greater than or equal to wi plus 1, then then discard pi comma wi. So what does it mean? It means that whenever the next ordered pair's profit is less than the previous ordered pair's profit, the next ordered pair's weight must be less than the previous ordered pair's weight. So let me check. 0 comma 0, 0 is less than 1, 0 is less than 2, 1 is less than 2, 2 is less than 3, 2 is less than 3, 3 is less than 5, 3 is less than 5, but 5 is greater than 4. 5 is greater than 4. So here this particular rule applies. What is that rule? Here pi value 3 is less than or equal to pi plus 1 value 5. However, and wi value 5 is greater than or equal to wi plus 1. So which is following the purge rule. That's why we need to discard pi wi. Here pi wi is nothing but 3 comma 5. So discard 3 comma 5 based on purge rule. The remaining sets will be as usual. So 5 is less than 6, 4 is less than 6, 6 is less than 7, 6 is less than 7. No issue. So now we have already determined s power 3. Now it is time to determine s1 power 3. s1 power 3 is nothing but add the fourth element's profit as well as weights. So fourth element profit is 6, weight is 5. Add 6 and 5 to all of the order pairs. Then what we are going to get? 6 comma 5, 1 plus 6 7, 2 plus 5 7, 2 plus 6 8, 3 plus 5 8, 3 plus 6 9, 5 plus 5 10. But this is not there, already discarded, so we need not to take. Next 5 plus 6 11, 4 plus 5 9, 6 plus 6 12, 6 plus 5 11, 7 plus 6 13, and 7 plus 5 12. So these are the values of s1 power 3. However, as we said previously, whenever the weight is greater than the maximum capacity of the knapsack, then we need to discard those ordered bits. So here 9 is greater than 8, 11 is greater than 8, 12 is greater than 8. So discard all these ordered bits. So now finally we need to determine s power 4. S power 4 value. So how could we determine s power 3 union s1 power 3? So just take the ordered pairs. So 0 comma 0, 1 comma 2, 2 comma 3, 3 comma 5 is discarded, comma 5 comma 4, comma 6 comma 6. So 6 comma 6 is here. However, there is 6 comma 5 in s1 power 3. So which is less than 6 comma 6. So that's why first take 6 comma 5, this one, and now take 6 comma 6, and then here 7 comma 7 is there, 7 comma 7 is there, take only one ordered pair, 7 comma 7, and finally 8 comma 8. So this is the s power 4 value. Let me have some space here. So this formula already we know. So I am rubbing this formula. Now we have calculated successfully s power 0, s power 1, s power 2, s power 3, and s power 4. So now the sets are ready. However, we need to determine the xi values, that is x1, x2, x3, and x4. How could we determine? The logic here is we'll start from fourth element. S power 4 is going to represent the set for fourth element, set for fourth item. So in this fourth item, if you observe all the elements of this particular set, the maximum profit we are getting here. The maximum profit we are getting here. So what is the ordered pair? 8 comma 8. So 8 comma 8 is belonging to S power 4, in which we are getting the maximum profit. Now what we need to check is whether this 8 comma 8 is available in the previous set. Here previous set is represented by S power 3. So now let me check whether 8 comma 8 is available in S power 3. It is not available. So that is 8 comma 8 does not belong to S power 3. If that is the case, then we have to give the fourth item the one value. What does it mean? We are including this particular item into the knapsack. When should we include? The maximum profit element must be included in that particular item's set, however, must not be included in the previous set. So now we have included x4, but what is the profit and weights values of x4? 6 and 5. So we need to subtract these 6 and 5 values minus 6 comma 5, because we have already inserted this particular item into the knapsack. So 2 comma 3 is remaining. Now the next step is whether 2 comma 3 belongs to s power 3 and 2 comma 3 belongs to s power 2. So now let me check 2 comma 3. It belongs to s power 3. 2 comma 3 is belonging to s power 2 also. So when should we include? Whenever it belongs to a particular set and does not belong to the previous set, but it belongs to both the sets. So now discard this particular item. What is it? This item? Discard third item. What does it mean? Its x3 value will be 0. We are not inserting this particular item into the knapsack. Now let me continue. 2 comma 3 belongs to s power 2. 2 comma 3 belongs to s power 1. So 2 comma 3 belongs to s power 2, but 2 comma 3 do not belong to s power 1. Does not belong to s power 1. So what does it mean? Now we should include this particular item. What is this item is represented? Second item. So the second item values must be 1. So I am including this particular value. What is the profit and weight values of x2, 2 and 3? So minus 2 comma 3. Now what is the remaining value? 0 comma 0. Let me have some space here. So now we have successfully included and calculated x2, x3 and x4 values. The items 4 and 2 are inserted, but Item 3 is discarded. Now let us check whether x1 must be included or discarded. So now what is the remaining value? 0 comma 0. 0 comma 0 must belong to s power 1, but 0 comma 0 must not belong to s power 0. So 0 comma 0 is belonging to s power 1, but it also belongs to s power 0. So what does it mean? Discard this particular item. Discard item number 1, that is give the value 0. So like this we have successfully found the x1, x2, x3 and x4 values. So based on these values we can find the maximum profit by using the formula sigma I is equal to 1 to n pi into xi. Okay, just what we are going to get, 1 into 2 plus 1 into 6, that is maximum profit we are going to get as 8. Okay, so like this we can solve this problem. Hope you understand the logic. That's all for now.